Okay, so one thing that we needed to do is we forgot to tell it to use the language C, which is right here in our project name, and then the language. If we were using C++, we could do that. And you can also set like versioning in it, like required minimum C 17 or 19.2 or whatever. So what I wanted to go through now is a little more about variables in C. Particularly, we can start with like int, float, and then double. So this is a 32-bit number. This is, I think, 32 bits as well. And then this is 64 bits. And then you can comment this out. So you can assign in this way, like equals 0. I tested this out a second ago before I realized I was messing something up. I didn't do the video correctly. So like I can print out, if I want to print this for reference, which oftentimes you do, you start it with the percentage sign, and there's I for integer, and you have like D for something, and F for something, and P for pointer. We'll get through all that. So this is X, and then I want to show something interesting about kind of what goes on with Y. So you can see Y is not actually an integer, it's a floating point number, meaning it has decimal precision. Shit, that's from a previous version. Okay, so you can see how our printout here, they're both 0, meaning that if you define, if you feed an integer, or sorry, if you feed a floating point into this integer, it's going to truncate it. So like if I had 5.5 plus 3.23.3, it's going to give you back 28.8, which is 28 to C if you're storing it in an integer. But if you had, like, let's say float z equals 0.5, and then you can print a float by using f here. If you don't use f, it has all kinds of problems because C is very specific, unlike Python that is not super specific. So there you go. You can see x, y, z. Great. One of the things I wanted to talk about is pointers. So we're going to create an int pointer called my pointer. And this is the syntax for a pointer. It's a little asterisk. So what does a pointer mean? So let's print f. And because I've done this enough times, I'm just going to print out this pointer, which is the %p is the syntax, and then you can feed it the pointer. So let's print, oh, I gotta close that string or it's gonna, there we go. Whoa, come back. Okay, that's for my own eyes because I like it that way. CMake, make, yay, my executable. So you can see this isn't the memory address of the pointer. So let me do a little comment here and copy that there. This is not the memory address of the pointer. This is the actual variable stored at this pointer. So if I did this, let me, I don't remember the syntax for what I need there. Let me figure it out. Okay. This dereference is the memory address of the pointer. So at the memory address this, we're storing this value, which is weird, but the usefulness of that will come through in a little bit. Now I want to show something that happens if you were to try and say, well, you might ask yourself, well, let's take this memory address, what's stored here? Well, the way you would do that is by dereferencing, which looks like this. So you would expect an int back because pointers can only point to integer objects and it can only retrieve integer objects. So whatever is here has to be of type int. So you can see that it has initialized this to a garbage value because there isn't anything here yet. We haven't initialized it. So then you're asking, well, how do we do that? So depending on your sequence, your order of sequencing, you can get away with some things. But typically you would do it like this. So what you're saying is this is your int pointer and you're allocating the space for size of an integer. Great. This memory allocation is part of this standard library include that I snuck in here and didn't say anything about. So if I took that away, it would give me an error that I might actually do, because I want you to see the error. So let me take that away. So if you don't include a header file in C++ or C, a lot of times it'll tell you like warning, 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 include this or provide a declaration. So if you don't include the header file, it doesn't know what this malloc memory allocation function is. And we'll get through kind of what do we mean by that in a little bit. So let me copy and paste this, and then the standard library. And let's go back and redo the CMake and the make. Yay. Okay. So now what we're looking at is, let me actually do this. I should definitely have shown this part, because that'll make our printout more clear. Okay, so we have the value of this in memory, right? Which I guess changes periodically, or when you rebuild your make file or whatever, when you allocate. So it's because you've allocated on the heap, and it's not just allocating wherever. So there are two different types of memory. You have the stack, which is when things are known. Then you have the heap, which is dynamic memory that you manage. So a pointer is dynamic memory. It's not static memory. An integer is an example of static memory, because you can, for example, free a pointer. And what that does is releases that dynamic memory. Why is that useful? We'll see as your program scales. You actually want that management. So now we can see that this has no longer been initialized to a garbage value. It's actually initialized to 0. So, well, what can we do now? If we want to access this, which is now 0, I'll do a little arrow like this. If we want to access what's here, we use this operation, which is called a dereference, and then we set it equal to maybe 10. What this does is says, okay, this is my pointer variable at this memory address, which stores this memory address. Go to this memory address and set this equal to 10. And then if we print this out again, we'll see what it does. So you can see now it's been set equal to 10. One thing that's really useful in C is that you need to pass structures by pointer, because you want to access it directly and edit its memory. And what we can do an example of that here. So let's do that. So let's make a function that's void and says like change variable value. And then let's call it change var val, so we don't have to sit here and type all day. So we have to define these functions before main. And then let's include our prints so we can see where it goes. And then I'm going to suppress all of this output from here to here. Now, inside change var val, inside finished. And then let's do a quick compile before we do this. So let's also suppress all of this so that we don't have to see it. Okay, so the way you would call this function is just like this. And then you have your termination semicolon after. And we'll see that it should go inside and print out. Inside main, we hit our first print. Then we hit our change var val, so we jump up here. Inside change var val, finish change var val. And then we hit this print down here. Great. So let's say we want an int x. Maybe we'll do a little x. So now we take and we declare our int x equals 5. And let's pass it 5. And then what we're going to do is we're going to print this f before and after the change var val. So, oh, I guess I can just do that. That's kind of funny. Okay, so inside of var_val, we're going to say x equals 6. Just change it by 1. So let's see what it says. Now, so we can see inside main, x is 5. We then go to our change var_val. We go in, we set x equal to 6. And then we come back and x is still 5. Great. The reason this happens is because we're passing a local, not a local copy, that's like zone scoping. We're passing a copy of x. So we're going to go into wherever the memory is in x. So let's say it's like 0x0053 or something, and that has the value 5. So we're going to grab this value 5 and we're going to send it to this function. Whatever happens here is local, meaning it doesn't come back to the rest of the program after this function finishes. There's a way we can fix that, and it's by passing this value as a reference. So what this is this is the memory address of x. And then this is the pointer notation. So a pointer is a stored memory address. So what we're saying, let me comment this out, is we're saying take the memory address and pass it to this, right? So this provides you with the memory address. If you remember our examples from earlier when we did the my pointer, right? Like we were able to return the memory address with this ampersand, it's called. And this variable is a memory address. So let's assign x with our pointer notation and watch what happens. So you can see that this actually changes the value of the function. And that's fairly useful because let's say like if x is greater than 15, we want to change this. And if it's not, then we don't. Then we don't change the else x equals x. You don't have to do this, but I think it's helpful for logic when we try and explain something. Oh, oops, what am I doing? That's right. There we go. So you can see that it actually operates on this logic, and it does so outside of your function, or outside of your main routine. And that's pretty useful because as your program grows in complexity, you don't want everything to sit inside main. I mean, look at how much code. It's already 69 lines AE. And all we've done is add one function and talk a little bit about pointers and stuff. So what if now I'd say 25? Let's see what happens. We can now see that this value has been set equal to 6 because x was equal to 25. I don't know what this logic means, but it's an example of how pointers actually work. And I'll go through it one more time. I'll go through this one more time as like one more time through so we understand kind of thing, if that's fine. So we have x. We pass the memory address of x to this function. And we have to declare this variable as a pointer because what's going to come to us is a memory address. And if you remember down here, pointers store memory addresses, not values, right? Like this was the pointer, this was what the pointer points to, or the value of this memory address here. Okay, so this was our dereference operation, meaning we want to go to this address and grab whatever value is there. And we're going to bring it back and then evaluate this logical statement. If it's true, we're going to take this value and assign it to whatever memory address is there, right? We're saying, well, I want to go here and assign this value to 6, 10, whatever we want to assign it to. In this case, it is 6. Else, we're going to take the value at the memory address pass through, and we're going to assign the value at the memory address that was passed through to the same value, which is ultimately, we don't even need to say this, but you can, just for the sake of like comparison and logic and whatnot, that's what we're doing here. So that's what a pointer does in this context. You can also pass pointers themselves. So for example, I would have to initialize this, right? If I pass this, let me suppress this as well now. If I just pass my pointer here, I can do that, but it's going to compare with 0 because that's what pointers get initialized to. Great. So now we can add our print statements like this, before and after, and then we'll change this x to pointer, and then like this. But we have to dereference it because what we're going to print out is a memory value, and we don't want that. We want what this memory value stores. Great. Okay, so let's do that again. Make, and then run the executable. So now you can see it's 0, it stays at 0 because it's initialized to 0 by this statement, which allocates the memory size of an integer pointer to my pointer. Great, that's the variable. This is a whole thing you can go through. Well, this will make more sense when we get to arrays and whatnot. Because basically the idea is you have to allocate the right amount of space for your array. This makes way more sense in the context of an array, but you should still do this to initialize your integer pointers so you don't have problems. So now, after this gets initialized, I can say things like my pointer equals 17. So that'll be set to 5. So dereference the pointer means go to this memory address and set this equal to 17. Great. Oh, I'm so dumb. I'm just passing it nonsense. Great, you can see it came in as 17 and left as 6. What I want to show here is that I didn't need to say, don't need this syntax. Why is that? Because the pointer itself, this variable is a pointer itself. What we did before was pass by reference, which would return the memory address we're looking for. So like, let's say we had this variable x. So we have x, and x has a memory address and a value of 5. When we use this gives us back the memory address, which is a pointer, and that gets stored in this local variable int pointer x. So int pointer x has its own memory address, which could be anywhere, and then it now holds 0x04. So this is what that pass looks like. This integer pointer has its own memory address, but it holds the value of the memory address of x because we passed x like this. I hope that makes sense. But that's pointers, and those are the two common ways you'll see things passed, and why you need to use this to pass by reference, and then if you declare a pointer, you pass the pointer as itself, like this. So that's what I wanted to get through in this video, and then in the next one we'll go through how to make arrays and allocate space for them, and then this will make a lot more sense of what we're actually doing here.